Okay, the equations of two lines are given. The equation of the first line is r equals I plus 4j minus 2k plus lambda times I plus 3k, and the equation of the second line is ai plus 2j minus 2k plus mu I plus 2j plus 3ak, and where here a is a constant. Now the first part of the question is, for all values of a, show that the lines intersect, for 4 marks. Now before continuing, it is a good idea to express the equations of the lines in the column form. This is in the row form, look, like in the row. So if we just express this in the column form, that is, for the first line, r is going to be 1i plus 4j minus 2k, so 1i 4j 2k minus 2k plus lambda I plus 3k. 1i, there's no j, so that's 0j. 0j is 0, so hence there's no j here, and 3k. Now this and this, they are the same thing. We write the I here on the first row, we write j on the second row, we write k on the third row. Thus they both represent the same thing, but look, this is more easier to work with, and if we just use this form, the I, j and k will create some problems. So it's a good idea to express the equations in this form. So let's express the second equation in the form like this. So a 2 minus 2 plus mu I plus 2j plus 3a plus mu I is 1, 2 and 3a. Okay, so we have expressed the forms, the equations in a more easier read format. Okay, so now look, this is one line and this is another line. Now it says the lines intersect for all values of a, and we have to show that. Before, look, the equation of the line is this. That is to say, at any point of the line, the coordinates will be given by this. So let's look at this first of all. Okay, just simplify this. We will get that r equals what? 1 plus mu, 1 plus lambda, 4 plus 0, that's 4, and minus 2 plus 3 lambda. For the second, it's going to be a plus mu and 2 plus 2 mu, plus multiplying and adding and multiplying, minus 2 plus 3a mu. So as you can see, this gives this and this gives this. Now these are the coordinates of any point on the line. This is the x coordinate, this is the y coordinate, and this is the z coordinate. Same here, x, y, z. And if this is the line, r equals this, then at any point on the line, the coordinates will be given by 1 plus mu, comma 4, comma minus 2 plus 3 mu. So this will give the coordinates for any points on the line. Now the lines intersect. So at the point of intersection, we know that the x, y and z coordinates for both the lines are equal. That's why it's the point of intersection. That is to say, all the coordinates are equal. X coordinate of r equals x coordinate x coordinate of this line equals x coordinate of this, y coordinate of this equals y coordinate of this, z coordinate of this equals z coordinate of this. The coordinates are equal, and we know that the coordinate at any point of the line is given by this and this. For the first line, the coordinates given by this. For the second line, the coordinates given by this. And at the points of intersection, the coordinates are equal. Okay, so this is 1 plus lambda equals a plus mu. X coordinates are equal. Y coordinates are equal. And lastly, z coordinates are equal. The coordinates are equal. Now remember, this is I, this is z, this is k, and we write xi, y, z and zk. Okay, x coordinates, y and z, x coordinate, y coordinate, z coordinate. Now for any when in vector questions, if there's a point of intersection, we just do this. We equate the coordinates, and then we solve any of the two coordinates to find the values of these here. Maybe they are called parameters. Okay, I don't know, but I don't know what they are called, but okay, I don't remember. Parameters, I think. So when we equate, we get three equations, and then we solve any of these. We solve any two of these three. We either this or this or this or this or this or this, and we find the value of the lambda and the mu. Then we substitute the obtained values in the third equation, and if it's satisfied, then the lines intersect. That is to say, if we solve these two and get values of lambda and mu, and we substitute the obtained values in this equation here, which we have not taken, then if the values obtained from these two satisfy this equation, then the lines intersect. So let's begin. From this equation, we get mu equals 1 plus lambda minus a. So 1 plus lambda minus a. Okay, subtracting a from both sides. Let's call this equation 1, and let's call this equation 2, and this equation 3. Now substituting the value of mu in this equation, we get 4 equals 2 plus 2 mu, but mu is, look, mu is 1 plus lambda minus a. So putting this here, we get this. This is 2 plus 2, 4 plus 2 lambda minus 2a. Cancel out, therefore 2 lambda equals 2a, and we get a equals lambda. Okay, lambda equals a. Now let's substitute this in equation 1. Substituting the value of lambda in equation 1, we get mu equals 1 plus lambda minus a. Lambda is a, so a minus a. Therefore mu equals 1. Okay, so from equations 1 and 2, we got the values of lambda and mu. Now in order to see if the lines intersect, we need to put the obtained values in this equation. So substituting the values of lambda and mu in equation 3, we get minus 2 plus 3 lambda plus 3 lambda, that's 3a, equals minus 2 plus 3a lambda. What's lambda? Lambda is, okay, minus 2 plus 3 lambda. Lambda equals a, so minus 2 plus 3a equals minus 2 plus 3a mu. What's mu? Mu is 1, so it's 3a. Minus 2 plus 3a. And look, the left hand side and the right hand side are the same. Therefore, the lines intersect. Lines intersect for all a values, because whatever a is here, it will be the same here. So they are equal. So remember that when you have to show that the lines intersect, you equate the coordinates. You'll get three equations, and you solve any two of the three to get the values of the these things above. It may be S, it may be T, it may be represented by letters, but in this case it's represented by Greek letters. You solve 2 out of 3 and obtain the values of the parameters in front. Then you substitute the obtained values in the equation you have not taken, and if that is satisfied, then the lines intersect. So in this case we took these two, obtained the values, and substituted in this equation, and voila, satisfied, and the lines intersect. Okay, thank you.